Okay, this is a problem involving complex ion formation. We'll start by writing out the dependent equilibria. As we can see that this involves insoluble salt and the formation of a complex. So we start with our insoluble salt. And we see that we're going to be making this complex that has two cyanide ions in it. So we are going to combine our cation with 2 moles of cyanide. Alright, so our net reaction is found by adding these two equations together. The products stay on one side, the reactants stay on the other side of the arrow. And we see that silver ion is not going to appear because it's produced and then consumed. Alright, so here's our net reaction. The equilibrium constant associated with this first one is KSP, it's a solubility, and this is the KF. So in the case of the dependent equilibria, when you sum these together to get a net reaction, the K net is going to be equal to the product of these two individual K's. Let's calculate that out since we have our values. And mathematically that will equal 5893. Okay, our ice table is that this is a solid, so we don't care, it's not going to appear. The cyanide ion concentration starts at 1, and we're going to lose 2S for every S moles of the salt that dissolves. We don't have any of our products. We gain S and S of each product when this occurs. So we have 1 minus 2S, S, and S as our equilibrium expressions. So we know that K is going to be equal to our complex ion multiplied by our chloride ion concentration divided by the cyanide ion concentration squared, and the solid doesn't appear. So let's put in our values. So K net is 5893, and we have S, and Cn squared is 1 minus 2S times 1 minus 2S. Okay, I've written it this way so we can see easily that this is a perfect square. Okay, so to simplify this, we're going to take the square root of each side. So the square root of 5893 is 76.8, and that's going to equal to S over 1 minus 2S. Alright, so let's cross multiply so we can solve for S. 76.8 times 1 minus 2S is equal to S. We'll use a distributive property to find out this expression. So we have 76.8 minus 153.5 times S, and that's equal to S. So we're going to combine like terms so that S is by itself on one side of the equation. So we add 153.5 times S to both sides. Okay, so we have 1S plus 153.5S, and that's going to equal 154.5 times S. And the other side of the equation, the other side of the equation is 76.8, and that's equal to a positive 154.5S, and S is therefore going to be equal to 0.497. Alright, so now that we have S, we can go back and answer our question. The question is, what is the concentration of the complex, the iodide ion, and the cyanide ion in solution? Alright, so the cyanide ion, okay, so first of all, S is its molar solubility. So S is going to equal the concentration of our complex and concentration of our iodide ion. And again, you can see that in our ice table. So that with 2 sig figs is 0.50. The solubility of the cyanide ion is equal to 1 minus 2S so that is effectively 0. Okay, in reality it's probably just going to be a very low value.